Hi, my name is Leo G from Grade 8 Politeness, and in this video I will give you a simple introduction to electron configuration. In atomic physics and quantum chemistry, the electron configuration is the distribution of electrons of an atom or molecule or other physical structure in atomic or molecular orbitals. Here is an example of an electron configuration. Electron configurations of atom follow a standard notation in which all electron-containing atomic subshells, with the number of electrons they hold written in a superscript, are placed in a sequence. When assigning electrons to orbitals, we must follow a set of three rules: the off-bow principle, the Pauli exclusion principle, and Hund's rule. The off-bow principle: in an atom, electrons occupy the orbitals in order of increasing energy. The lower energy levels are filled up first before going to the higher ones. This order of filling up orbitals is known as the off-bow principle. Hund's rule: for a set of orbitals of equal energy, such as the three 2p orbitals, electrons tend to occupy the orbitals singly before any pairing occurs. This is known as the Hund's rule of maximum multiplicity, proposed by Friedrich Hund, a German physicist. Pauli exclusion principle. According to the Pauli exclusion principle, no more than two electrons can occupy an orbital, and these two electrons must have opposite spins. This is why an s orbital can only hold a maximum of 2 electrons. A set of p orbitals can hold a maximum of 6 electrons. D orbitals 10 electrons, f 14 electrons, and so on. Now, I will show you how to find an electric configuration of an element. So, let's talk about nitrogen. So how can we write the electron configuration for an atom of nitrogen? This is what nitrogen looks like in the periodic table. So, the higher these two numbers is the mass number, and the smaller of these two numbers is the atomic number, which is an integer. Now, we need to know is that in the first energy level, you have the 1s sublevel. In the second energy level, you have the S and P sublevels. In the third energy level, you have S, P, and D. For nitrogen, this is as far as we need to go. The S sublevel can hold 2 electrons, and the P sublevel can hold 6, and D sublevel can hold 10. Now you want to write the electron configuration until you get a total of 7. Now, for an atom of a nitrogen, it contains 7 protons and 7 electrons, but we're focused on the number of electrons because we're writing electron configuration for ions. That number could differ, but for atoms, you just need to focus on the number that is on top of n. So the number of electrons in this problem is 7. So here's what we need to do first. Start with 1s. So I'm going to write 1s2 because s can hold up to 2 electrons. Next, move to the 2s sublevel. 2s can hold also 2 electrons. Then after 2s, you want to go to 2p and then 3s. Now 2p can go up to 6 electrons, but we only need 3 more because if you add the exponents 2 plus 2 plus 3 equals 7. So once you get this number of atoms, you can stop. This is the electron configuration for an atom of nitrogen. This is the end of the video. I hope you learned something, and thank you for watching.